one next set of directions you should run into, this is all rewriting messy expressions, is rewrite as a sum or difference and simplify. So I think mostly what you should see here is quotients that we want to rewrite as addition or subtraction problems. So the big fraction bar is the big operation. This is a division problem first and foremost. So there's a couple of the ways that we can do this. One is we could factor and cancel, but even if you can't factor, you're still supposed to figure out how to write this as a sum or difference. So one of the things I wanted you to try out in this one, just so you know it's out there as an option, sometimes when we don't care about ending up with a single fraction in our answer, we just split the fraction up, right? So we know that, here, let me write a little side note. To add fractions, we'd say a over b plus c over b is equal to a plus c over b. That property works in reverse, right? If your a plus c is just counting up how many pieces of size 1 over b you have, you can split it back up and say, okay, then that was a pieces of size 1 over b and an additional c pieces. So we can split this into and these should look similar to some of the problems we were trying to factor earlier. So feel free to try out the factoring that we did earlier as well. It can simplify them really nicely. This one's going to be an x to the negative 1 times 5 to the x over x to the negative 2 times 5 to the x. So I do see a little bit of canceling I can do right off the bat with the 5 to the x's, hopefully without thinking about it too hard. The other one, 5 to the 2x over 5 to the x, that works out nicely as well. What you would do there is subtract exponents, or you can visualize it as canceling, it's up to you, and say 5 to the 2x minus x, which is just going to be a 5 to the x left over. For the x's, you can either rewrite them as 1 over x squared, or you can use your subtraction rule there as well. In fact, I'm being silly. For the first one, x to the negative 2 over x to the negative 2, I think that's an easy cancel. I can just say I have 1 left. For the second one, you do want to be a little careful. Do I end up with x's in the top or the bottom? So I'm going to combine that with the subtraction rule and say that's x to the negative 1 minus negative 2, which becomes a plus 2. So it looks like we are actually going to end up with x's in the top. So I have 5 to the 2x minus x, which is x, minus x to the negative 1 plus 2, which is 1, which we don't really have to write. So that simplified actually really nicely and is now written as a difference. So you can try factoring, totally great. I'm not against it, but also practice the splitting up fractions trick a little as well. I want you to be able to do either one of those things. Okay, so again, we could factor and try and do some canceling, and I actually think that will help. It'll make things a little cleaner, but I'm going to jump right into splitting this up. Remember, you cannot split up the denominator. That's not allowed. The denominator tells us how big our pieces are, but the numerator is just telling us how many pieces. So we can split that up instead of saying we have 2t to the 5 halves minus t to the 3 halves minus 3t to the 1 half pieces of size 1 over 3t to the 3 halves. You can say I have 2t to the 5 halves pieces minus t to the 3 halves pieces, size 1 over 3t to the 3 halves, minus 3t to the 1 half pieces of size 1 over 3t to the 3 halves. So you can split up the fraction. And you can do some, again, just cancel or subtract exponents, however you think about it. So the middle one I really like. We can cancel the t to the 3 halves altogether, and it's just going to leave the 1 in the top and the 3 in the bottom. For the first one, this is going to become t to the 5 halves minus 3 halves, which is 2 halves. So I'm going to have the 2/3. And then I'm going to have a t to the 2 halves, which is just a t. And you can leave the t in the top, 2t over 3, that's fine. But you can also rewrite that as a coefficient. So either way, 2t over 3, which is the same as 2/3 of t. Okay, minus 1/3. the last one gets a little bit more interesting. The 3's cancel, but this becomes t to the 1/2 minus 3/2. So it's t to the minus t to the negative 2/2. So I am just going to go ahead and take that one last step and rewrite that without the negative exponent. Whoops, I'm thinking about 1 over t's, but that's not there. 2/3 t minus 1/3 minus 1 over t. So there's a fraction, a division problem, rewritten as a subtraction problem again. Okay, I don't know how many of these I have. Is that the last one? Yeah, okay, one more, so let's go ahead and do it. Here, same thing, the top is a difference. This is the subtraction, that's the big operation. So we're going to split it up and say, okay, I can write that as 4 root 3y minus x over root 3y minus x minus 5y over root 3y minus x. And I can do a little bit of canceling. So I'm going to say I have 4 minus, and then I can't really cancel there. So really, I would be pretty happy with just like this. But we are practicing our rationalized denominator, so maybe in this one I'll go ahead and do that step. If in doubt, go ahead and rationalize. It's true that later on we won't always care about the radicals in the denominator, but I would rather have you do that step at this point and practice it than not do it when I was wanting you to. Otherwise, always you can ask. Over 3y minus x. Okay, so really I'd be happy with either of the last two for these directions. Rewrite as a sum or difference. All right, so hopefully that gives you some ideas. So on that quotient rewritten as a sum or difference, just try splitting the fraction up and simplifying.